Yes, in the parking lot where I put my car, one of the porta potties had blown over on the way in,
Oh,
which,
That's
that's
never
some
great.
crap, right? That's some holy crap.
that
right there.
is crap. Yeah.
Yeah, so that is never a good omen when you see that happening. But we are contractually obligated to be here and make it through the end of the semester, and that is what we are going to do.
Mhm.
So, awaiting you over break is a formative assessment. That is not due until the Monday after, so December 2nd-ish,
Mhm.
something like that. So you got plenty of time to work on that. That will give you hopefully an opportunity to review before we reconvene as a class. You can be working on homework 5, which is due the following Monday, December 9th. That is over example 4B. And I just gave your last homework to the TAs to start over this example, and they will let me know when they are ready to help you with that,
They're
and I will
excited.
open it. I know, it's getting there. So, point of the story, I know that all of you have a million competing demands right now, and you're probably exhausted. So you can decide to get all this stuff done ahead of time and put this class to rest, or you can decide to put it off until the last minute and get something else done instead. It's your call. So I'm just putting everything up so that you can decide for your own selves how to make this roll. So we, in this last unit, are talking about interaction terms.
Mhm.
Multiplicative combinations of variables to answer research questions about what? New vocabulary word that starts with an M.
Moderation.
Moderation. Yes,
Not
indeed.
mediation.
Not mediation. Exactly. No,
Thanks for the videos.
they are different. Mediation is regression with a better marketing campaign behind it. That's what mediation is. Yes. We will talk about mediation in the generalized linear modeling class at the end if you want to come back for that, or you can check that out on your own. It's a whole topic of research, but it's a very common thing. Unfortunately, univariate models like this will not get you very far into mediation territory, so that's better as a multivariate set of models, which is what we do at the end of generalized. But for now, we can talk about univariate and moderation. So the idea of moderation is the effect of a predictor depends on the value of some other predictor. And your predictors in moderation models can be any kind. They can be binary, they can be ordinal, nominal, continuous, continue-ish, piecewise, anything you want. And it's up to you how many interactions you have and what kind. The only rules really are to remember that you have to have the main effects as part of the interaction. So when I say main effect, what am I talking about?
Beta 1,
Beta 1. So for example,
the variable.
All
Yeah.
those with a single variable with a fixed slope.
yes, so like for example, for homework 6 on this page here in capital letters. So in this example, we have if interaction of sex by age and sex by grip. So one of the main effects, correct, would be beta 1. Age is part of that. Another one would be the main effect of grip strength as part of this interaction, and then gender is actually part of both of these things. So these are now called main effects. We called them slopes before, so these are all still slopes, but now one variable all by itself is called a main effect slope. Interaction terms then are called interaction slopes. So in terms of the terminology. The other distinction that is relevant for vocabulary is marginal versus conditional. Marginal means unconditional. Yes. And conditional means simple.
Yes.
I know. It's terrible language, but it is what it is. So in this model, for instance, given that age is part of this interaction term, beta 1 slope is a unique effect of age after controlling for everything else, but it's specific to the value of the moderator being 0. So putting that together, beta 1 is the slope of age specifically when sex is 0, which in this example is the min.
None or nothing.
Min are the 0 in this one. That's all I'm going to say.
I can say it.
You can say it. Likewise, if we have this simple effect of grip, this conditional unique effect, that is also specific to men for the same reason in this model. So what these slopes mean is entirely driven by the context of the model and what's in it. It's always very specific. You have to look at the list and know everything else. There is a main effect of gender right here that is conditional on 2 things. So if we put that together, this is the gender difference for what kind of person. What values of the moderators?
85 for age,
Yeah, age 85 and
9 for grip.
yeah, grip strength of 9 pounds. Very good. So why that matters is, let's say that this effect was non-significant. It's like, well, gender doesn't matter. So, well, no, gender doesn't matter in this type of population, but it could matter elsewhere. So we have to keep in mind that these things are specific to values of the moderators and think about what the other potential values of that slope would be at other values of the moderators. So last time we did the main effects model. Do we need to do anything with that again, or are we feeling okay with those? You've seen it 2 times already, so at least for this one. So in this case, without any interaction terms, these would all be marginal or conditional without interaction terms. Marginal. Like, this is the age slope for everybody. This is the grip slope for everybody. This is the gender slope for everybody. Once we get into the model with interaction terms, that's where we have to make this distinction. So we did this Stata version of this model last time. Do we want to go back over any of that, or just look at the R version? Any preferences?
Stata,
You like the Stata?
because I'm working on Stata.
Because you're working with Stata. Well, you're here. You get to make the call. Zoomers, anyone want to vote? Got 1 vote for Stata to start with. No votes from the Zoomers yet.
They checked in and then checked out.
Don't know. Well, there could be. I don't have the 3 dots that shows that they're typing in the chat. I really wish they would have that.
That's actually a fun feature,
It's useful.
especially when your child is someplace else.
Yeah,
They
the
can
3
get my
dots.
message.
Except when the 3 dots just stop and then there's no message. And it's like,
Yes.
what did they just erase? But no. Okay. Well, since you voted, you win. So in Stata, we are adding 2 interaction terms. The purpose of these interactions is to answer the question, do the effects of age and grip strength differ between men and women? That's my question. So to do so, in the regress command, unlike other commands, you do not need to make the interaction terms as observed variables. There are certain routines in software where you do, but this is not one of them. So this #/# here creates the multiplicative combination for you, does not have to exist in a data set somewhere. And by the way, there is a way to do this with less typing that I am deliberately not showing you. But as a bonus, if you put 2 hashtags in there, then what that does is imply the main effects that go with it. So a 2 hashtag is all the main effects and the 2-way interactions that go under it. And if you had like 3 variables in here, then it would be the main effects, the 2 ways, and the 3-way interaction. Like, it does all the underneath part for you.
So you don't have to do all the long.
You don't have to
You
type as much.
shorten it.
It shortens the typing, but I am deliberately not doing that.
But is
to
it still listed
reinforce.
out separately like it's showing there for your output?
Yes, it will still estimate each of these slopes separately. It just shortens the code to request them. Yep. So, but I'm not doing that again because I want to drive home the point that all of these main effects need to be here for these interactions to be meaningful. So we know from the previous model that we had a significant model. This model is still significant. We talked last time, though, that the F value has gone down because we had 5 slopes before that captured like an F of 40 something, and now there's 7 that capture 30 because we added 2 that are going to turn out to not do very much. But if we go through the interpretations, and I'm going to not screw it up this time. How's that sound?
Wow.
I know, I screwed it up last time. I still feel bad about that, but I'm imperfect. It
Yay.
happens.
Good job.
I know. I am demonstrating humility. How's that? So what I screwed up last time was I lumped in the gender slope with these 2 when I asked this question. Now, these 2 effects of dementia. Dementia's still bad for you, right? Relative to the main effects model. So the N group means none. The future group is the first comparison for this slope. So if I'm in the future group, my cognition is predicted to be lower by 5.7. If I'm in the current dementia group, relative to the none group, my cognition is predicted to be lower by 16. Now, are these like for a man or for an 85-year-old or for grip 9 or any of that stuff? Are they conditional?
That's for everybody because they aren't interacting.
Yes, these are not part of an interaction term. That's what we have to look for. And therefore, these are the gender differences regardless of these are the dementia group differences regardless of gender, age, and grip strength. So it is true that these are controlling for. Like this is the unique effect of dementia after factoring in the common variance that is accounted for by age and grip strength and gender. But in terms of who these are the slopes for, they're for everybody. So this is a distinction I had to describe in the last class too. So I want to make sure this is clear. The idea of unique means like this is what dementia group brings to the table uniquely. Like picture your Venn diagram. This is not counting whatever's in common between the predictors that's also in common with your outcome. This is the unique part of the pie that only it got. But that being said, these are the dementia slopes for everybody, unconditionally, marginally. Okay? Zoomers, are we okay? Try again. Please? There we go. There's one thumb. I just don't wait long enough, I think. There's always like a delayed reaction.
Speed of light is slow.
Yeah. Speed of internet is slow. It happens. Now, what I screwed up last time. This is the gender difference.
You included that with the other two.
Yeah. So age, grip, and gender, these are all conditional. Not only are they controlling for everything else in the model, but they are specific to the values of the interacting predictors at 0. So we got to know where those are. So if I start with the perspective of the research question, does the age slope differ by gender? That's one question. So here's my age slope. Who is that for, again, given the moderator?
Gender.
Gender of? So this is, we're asking about the slope of 85 as the predictor. Gender is going to be the moderator to start with. So who is this the age slope for? It's not 85. It's not conditional on itself. It's conditional on the other one. For a man, yes. And I know that because the men are the 0 in this binary variable. So the reason it's not conditional on 85 is because it doesn't interact with itself. No, but it would if it's a quadratic
Oh,
slope.
that's true.
We had quadratic slopes of age, and I think that's what you're remembering.
Yeah, no, that's not what I was remembering. I just did a silly. And that's okay.
It's okay. It's absolutely okay. It is better to be wrong than vague. Wrong answers I can work with. Vague answers I can't. It's true. 85. So in men, for every year older you are lower on this outcome by about 0.2, non-significantly, but I'm much more concerned that you know what to do with the numbers than the p-values. In women, what happens to that age slope? The interaction with gender and age is negative also.
You become more negative.
More negative. So does age have a stronger effect in women or a weaker effect?
Stronger.
Stronger. More anything is stronger, yes. So the most common thing I see people screw up with this is to look at this and go, well, this is the age slope in women. It's not. It's the difference in the age slopes between men and women. More specifically, 0.29 is how the age slope differs in women relative to what it is in men, which is given up here. Interactions are differences in slopes, always. So that means to get to what it is in women, I start with what is the age slope in men, which is right here. I add to it, how does it differ in women? And the sum of these two things is what it is in women, because women are the 1, so I just need to multiply this slope by a 1. Okay. Let me show you in code. That might help, or it might make it worse. I'm not sure.
If that was continuous as opposed to 0, 1, that would be an entirely different thing, than how you interpret it, or?
If it were continuous, and that's gonna be the next model,
Oh,
by the way, then it's per unit of the moderator.
You're just gonna say per unit?
Yeah,
period.
for every 1 unit increase in the moderator,
Right.
this is how the slope changes.
Okay,
And for this case, there is only a 1 unit increase, so there's
Yes.
only one possibility.
okay.
So what I'm doing here is the rules of generating predicted slopes for any value of the moderator. Step 1, go into the equation. And if you're like, yeah, I don't write equations, okay, then step 1 is to go into your code. 6 of one, half dozen of the other, right? Like this, there's some coefficients stacked in front of it, but these are the ingredients. So if I want the age slope,
Mhm.
then the things in here that I need are the age slope, don't need the grip slope, don't need the main effective gender, nothing to do with dementia. I do need this because it has age in it. I do not need this because it doesn't.
No.
Okay, so I need 2 things, that one and that one. Okay. So these are the ingredients that create the age slope for any value of my moderator. Step 2, factor out the variable the slope is for. And there's no way for me to say this without the sentence ending in a preposition. I'm sorry, I just can't.
Yeah.
Factor out the variable the slope is for, and so I pull age out of here, I pull age out of here, stick it in the back. Now what's in the brackets is
May
what's
I?
left. Yeah,
You may just say, factor out the common variable.
factor out the common variable that the slope is for. Reminds me of a movie that I watched, I think it was the late 90s. It's Brendan Fraser, and he was a college student, and it was Joe Pesci, and he was a homeless person. Do you know what I'm talking about? With honors, I got it.
With honors.
The name of the movie is called With Honors, and why this is relevant to the story is there's a scene where Joe Pesci, as the homeless person, accompanies Brendan Fraser to class, and he ends up like giving some impromptu speech because the professor is like mocking him for being, a drunk homeless person or whatever. And so after he finishes his speech, everyone's clapped for him, and then he decides to leave. And then he says, "Where do I leave from?" And he says, "At Harvard, we do not end our sentences in prepositions." He says, "Okay, where do I leave from, asshole?" And so, touche. Well done, Joe Pesci. So that's what I always think of when I think of ending sentences in a preposition. It could be worse.
Could be much worse.
Where do I leave from? Factor out the variable the slope is for. And you can put your own ending to that sentence as much as you wish. But this is what we got. So at a minimum, we need the slope of age to make the slope of age. Okay. And so this also, I think, drives home the point as to why this is why beta 1 means the slope of age specifically in men, is because if we're talking about men, this cancels out because this is a 0 and we're left with just beta 1. But if we're talking about women, then we have to plug in a 1 here, and it's the slope of age plus the interaction term. So that's what I'm asking for down here. First for men, this is really for pedagogical purposes because I already had it up above. But then for women, I need 1 age slope plus 1 interaction between gender and age. And so that minus 0.52 is the sum of minus 0.23 and minus 0.29.
Yeah.
If you were to write this up for a journal, would you include all of that? Because there might be someone who's not as astute as in general models. And that's why you can include that apart from the male.
I would, but I would probably, it would depend on whether it's something that I need to report or just, and like move along, or report and interpret. So like in this case, I would probably not go to the trouble because the end of the sentence would be, the age slope does not differ significantly between
Right.
men and women, the end.
Okay.
Something like that. In the next examples, I have 2 significant interaction terms, and yes, I would, let me foreshadow. So there's going to be a sex by dementia group interaction eventually at the end of this big giant handout.
Well, this was only 19 pages, I
It's,
think you said? Or
this is only 20 pages,
20,
I think.
sorry.
Yeah, it was 19 yesterday, and now it's 20, so
It
something,
grew.
something moved around, I bet. But in the example, I'll show you here. In the results section here, I actually did do this. So, like, I have the interaction as this, and the resulting sex difference is a linear combination, and I actually wrote it out like that to show them like where it would come from. I don't necessarily see that commonly in results sections, but if you really want your reader to follow, particularly if it's a tutorial kind of paper. But then in the table, like I actually listed them as to like how I got the alternative slopes as linear combinations of everything.
Cool.
So then you can provide all of the information that's in your model, plus all the extra things that people might want to know in terms of additional potential slopes. Okay. Back to
Page, I don't know.
page something. Here we go.
Hey, that was good guess.
Yeah, that was a good guess. Okay, does that make sense that much in terms of, so the interaction is the difference between slopes. I can do the same thing for grip strength. So let's go to that one first. So then for the same reasons, these are the only two terms that would make up a grip strength slope. So once I factor out the variable, the slope is 4, then I'm left with this. And so in this case, I am starting with the slope of grip, adding in the interaction of gender by grip, which would be 0 for men, and 1 if it's women. So now the grip strength slope in men is 0.70, which is significant. The grip strength slope in women is 0.52, which is significant. And the test of the difference between them is in the model right here. And that difference is not significant. There's the p-value.
Mhm.
So putting it together, being stronger relates to better cognition. Agreed. In men and in women.
Mhm.
And the extent to which being stronger in grip relates to better cognition is equivalent between the genders. I would not say equal, I would say equivalent. That's a word that means like ish, equal-ish.
If you scroll over to the right a little bit within zero it is in there, in our interval.
Mm-hmm.
That's what I was just looking for.
Yep.
Cool.
Yep, the confidence interval for the non-significant slopes will overlap 0. Yep. So far we've learned that these two interactions are not uniquely significant. So the effects of age and grip do not appear to vary by gender. I can go the other way. Let's start with the effect of gender. That is a gap of 3.62. Who's higher?
Neil.
Men, yeah, because the women are the 1, so they get the negative that brings their score down. So specific to 85-year-olds with average grip strength, that's the gender difference favoring men. What happens to that gender difference in older people? A negative and a negative.
More negative.
Yeah, the gender difference becomes more negative as a function of age. And if I were to put this coefficient in a sentence, how would I do that? Want to try? This is what you were just asking me about like a minute ago.
Well, I'm sure it is.
Yeah? Or do you want to phone a friend?
I'm gonna phone a friend. I'm gonna phone
Oh,
Usama.
come on.
Okay.
I'm already on the call.
Call waiting.
Busy
Call back
signal.
Okay, so here's my gender difference in 85-year-olds.
Yes.
How do I put this interaction term coefficient into a sentence to describe what's happening in older people to the gender difference? The interaction coefficient is negative 0.3. I'll start you off. For every,
Okay, for every male,
other way. We're going the other way.
for every gender.
So we're interpreting so we're doing the interaction term from the opposite perspective now.
Okay,
So we're
from
treating
female.
age as the moderator.
Oh, okay. So for every age,
For every year of age.
okay, for every year of age, the coefficient,
Mm-hmm.
um, the coefficient value for male,
Yeah, for the effect of being the difference between men and women, gender gap, effect of being a woman, however you want to say it.
yeah, the effect of male and female
Mm-hmm.
varies between minus 3.62.
So this is what it is in an 85-year-old. What would it be in an 86-year-old?
For 86.
Mm-hmm.
For 86, it's going to go less than minus 0.29.
Yes, so lower again, so more negative. Yep, exactly right.
More negative, okay.
Yep. So putting that together, we'll call this the gender gap. Okay, that's the more intuitive way I'm thinking about what this coefficient means.
So the gender gap is increasing as you get older
The
between
gender
men and
gap.
women.
Yep, the gender gap is increasing as you get older by 0.3 per year of age.
0.3 per year.
Yeah, the slope changes by 0.3 per unit age. That's the tricky part.
Right, so
Yep.
it's coming down then, gradually.
The gender difference is growing, is the way that I would put it, as
Yeah,
age increases.
The gender difference is growing, but then the cognition is coming down.
Yes, so think of it as like a layer sort of system here. Like we start with the interaction dictates what the main effect slopes are gonna be, and then they bring cognition down.
Mm-hmm. Okay. Right, yeah. I was just wondering if we can have some visuals, so.
Oh, yeah, may I attempt a visual?
You may, I might even have
So let's
a
say that
picture in
this
here.
is the men,
There we
as
go.
they get older, their cognition gets lower.
Yeah.
Okay, the women are like this, the men are like this.
Okay,
Here you go,
Oh,
here's your visual.
sorry, yeah,
there you go.
I did not trust my elbows to get this right, so I just decided to make a picture. But yes, so this is a picture that you can think of, so if we go the first way, the x-axis in this picture is age.
Right,
And so we had the age slope for men as what was given directly by the model, that's the slope of the blue line. The age slope for men plus the difference in the slope for women given by the interaction term gets us to the slope of the red line. The fact that these slopes are kind of the same is evidenced by the non-significant interaction. These slopes are not different according to this model. Now, the gender difference is the gap between the lines.
yes.
So at age of 85 would be somewhere in the middle of the plot here. This would be women are lower by 3 point whatever.
Mm-hmm.
As age increases, that gap widens. So it's wider in older people, it's smaller and narrower in younger people. And yes, you are absolutely right that a picture is essential in talking about these things. It's essential.
Thank you.
And it's not just a picture. So this is something I see as an editor of a journal. I'm an associate editor of MBR, rotating off of it this year. One of the things that I see people do is like, see figure 1. Like there's this whole paragraph about all these results and then see figure 1. Like, come on, dude. No, that's just lazy. Like you made the picture, walk me through it. Like as seen by the slope of the dotted line, this is what this means. As seen by the difference between the lines, this is what this means. Like you got to help your reader interpret what you're showing them.
Are the confidence intervals on either side, is that the extended blue line and so forth?
That's what these are. These are built into Stata. These are confidence intervals around the predictions.
Okay.
Yep, and I'd have to look at the documentation to see if these are like 2 standard errors or 1 or
Well,
whatever it is.
I didn't care about that in particular, I'm just wondering about, what that
Yes,
particular
typically you would want to put some kind of error
Right.
bars on your points, because otherwise it like, well, this does look like they're different, but if you kind of look at how much they overlap.
Yeah, but
Yeah,
there is
there's-
a,
And the error bars around the predictions are not going to be the same as like the error bars around the difference. That's the other thing. Like those are different quantities. And this is only the difference of the predictions, not the difference of the differences. So this is, I know, the language is terrible. But point being,
yes.
the gender gap is literally the gap between the lines here. The interaction term is making it more negative bigger in older people.
Mhm.
And if we put the coefficient in there, the gender gap is getting bigger by 0.3 per year of age. So it's the other variable that you have to say per whatever. Now if we go grip strength, this is, let's see here, nope, sex, here we go, this one. The pattern of this is the same. The gender gap is increasing in stronger people. The gender gap is larger by 0.18 per pound of grip strength per unit. But since grip strength has a positive slope, the picture looks a little bit different, so I made that one too. So this is the effect of grip. It was significantly positive in both genders. The slope of these lines was not different. The way we're talking about it now is the gap between the lines is increasing with higher grip strength. So these lines are narrower than these ones out here. And all these points are just plus or minus 1 standard deviation. Like that's the range that's on this x-axis. If you wanted to, you could go the full range of the variable to show like all the logical possibilities. But just did just this much for now. Ba-doom. They're like, I got it. I'm good with interactions. Peace out.
Or I got kicked off.
Could be. Or the internet died. Yeah, that does happen periodically. Okay, let me see here. So I think we got through all the output except for this part. Effect sizes. So I will tell you, Stata folks, you have 2 choices when it comes to generating this information. One is NestReg. It does it for you. But that is requiring you to build your models sequentially, which is how I have homework 5 and 6 both set up, so that will work for you. So NestReg was demonstrated in example 4B. Do you want to see that again real quick? Would that be helpful?
I'd like to know the spelling of this code that you just said.
It is NESTREG. So I'm going to show you there's two choices for how to get this, like you add something to a model, does it help? And as long as you're adding more than one thing, you need to do some extra steps to figure it out. We talked about that in terms of our formative assessment last time. Hang on here, let me see if I can get example 4B to open. Maybe, yeah. I'm waiting for some mysterious error message to pop up again. Nope, it didn't. Okay. Towards the end of example 4B, I had done this in Stata, I believe. Yep.
Down, it goes down.
Yeah, so the NestReg command is on page, this is, what page? 8 here. NestReg : and then regress, and then when you put things in parentheses, it's like what to add next, what to add next. And so it spits out all the separate models. So like this has age first, then age and grip, then grip, age, grip, and gender, and so on. And so it has the separate results, but the thing that tests the difference is this little piece right here. So you have the F-test for the block. So the first one is adding age to an empty model. So it's just giving you the overall R-square from age. Then we are adding grip strength in this example. So we have the R-square now has increased. You can see it was 0.029 and now it's 0.075. This is the change in the R-square, but it's also a specific kind of effect size. Remember which one? It's partial or semi-partial eta square. What do we think?
Semi.
This is the semi. Yep, this is like how much of the cookie did you eat? Did you eat a quarter of it, or did you eat half of what someone else didn't eat? Half of a whatever? So yes, this is semi-partial eta square right here, as change in R-square. This is how much the R-square increased after adding the next thing. So you can get a significance test for whatever you added, and it does it whether there's one thing added or 2 things. Technically speaking, we only need to do it if there's 2 or more. But the change in the R-square you would need either way, and so that is provided to you right here. So you can use NestReg to get everything at once. If you don't want to do that, or you have a situation where you're not doing hierarchical models like that, here's another way. So what I'm trying to do here is ask, did the 2 new interaction terms improve my model? And I'm doing that with a command called test. Now this is a generic command that works with a whole bunch of different routines. I use it in my other class as well. So this is saying, hey, can you take that interaction slope and pretend it's 0? And can you take that one and pretend it's 0 and tell me what happens? And the parentheses tell it to make them two slopes tested simultaneously as opposed to like adding them together or something like that. This is not building a linear combination. This is a joint hypothesis test that both of these things are 0 at the same time. And so I get an F for that. Note degrees of freedom is 2, because that's how many things we're lumping together. The denominator degrees of freedom is whatever it was in the model, so the 542. And my F is 0.81, meaning we actually did worse than chance in adding these two things, and the p-value is decidedly non-significant. So if these two interaction slopes were really 0 in the population, we would get slopes this big or bigger, like 44% of the time. So well within expected sampling fluctuation of noise around just what you could get from going from sample to sample. So that's my significance test. The effect size is by how much did the R-square increase after I added these things in. So to do that, I have the sums of squares from the previous model that I had already saved. So this $SS main, when you see $, think someone's going to pay me because I learned this someday. Okay, there's your key to remember what that symbol is. $sign gets used a lot in complex stuff, actually. I think that may be why. Where that was made was in the main effects model. So I stored the results of the main effects model, and then I made a new saved like environment variable. It's not in your data set. It's like within the state of memory. And it's called SS main because that's what I named it, sums of squares for the main effects model. And it is pulling the mean square for the model that is right here. So it is saving that number with this label. The reason I'm doing that is because otherwise, to do the computations, I'd have to manually input this number into a calculator. And that means anytime my model changes, I'd have to like fix it. And it's very tedious and error prone. So I'm telling it, hey, save this number as this name SS main. Now I'm going to use it down here to say, hey, can I get how much more the sums of squares for the model is for the current one with my two interactions minus what it was before? So this is the increase to the sums of squares that results from adding these two new interaction terms. I can then use that new number, the result that it computed, to make other effect sizes. So here's what it would be for partial. What'd you get over what's left over as the denominator versus semi-partial is what'd you get over the total, model plus residual. And so then these values are printed out. And lo and behold, the semi-partial R-square is the difference in the R-square that results from adding these two things. So, point of the story. Whenever you're adding more than one thing to a model and you want to test whether that one thing is significant, you need some kind of F to do that, and then you need to generate some kind of effect size for it. NestReg will do both for you if you do it hierarchically. All right, that's a lot of stata. You feel better about stata?
Thank you.
You're welcome. Anyone else feel good about stata? Erica's back there making functions. Are you going to fix all my handouts for me? Maybe?
I'm actually working on the homework right now, but
Okay.
I will get back.
She's doing your homework right now.
She'll be done by the end of class.
Yeah, here's the thing, folks. Like the TAs, they're doing the homework for real because I did not teach them this class. They had it with someone else. And so that person gave completely different activities and homeworks. So they're doing it for real. So, not so bad, right? Not so bad. Okay. All right. Then here's some pictures. So this is how I made the pictures. And by the way, in homework 6, this will be your best friend. Margins and stata is beautiful. This says, hey, can you give me a range of predicted values at these levels of your predictors? And for this plot, I wanted to hold dementia constant at 0 because I'm not interested in that right now. To make the age by gender plot, I held grip strength at 6, so I'm holding it at -3 in the centered metric. Centered at 9, so 6 is -3 instead. And then I'm saying, give me age starting at -5 in increments of 10 going up to 5. So that's just filling in -5 and 5. But you can see, like if I wanted it for -5, -4, -3, -2, -1, Put a 1 there. And now I've got 10 values instead of 2. It's beautiful. Love this thing. Same with gender here. Start at 0 in increments of 1 and go up to 1. And V-squish, by the way, just gets rid of extra spaces in your output. I think it stands for vertical squish. I think it's funny that they called it squish.
Yeah.
Like,
That's
that's
just fun.
that's a word that I would use. Like, that's not a programmer kind of word. But then after you ask for margins, you have the options to throw those predicted values in a plot. And so that's how I made these. And then graph export, save them to a subfolder in the example with this name. And by the way, these come up as separate windows when you run Stata. You can double click in them and edit stuff in it. So you can change, like, the y-axis here, by the way. Do you see what this is called? Linear prediction.
That sounds exciting.
No one wants your y-axis to be called linear prediction. If I were making this picture for publication, what should I call this instead? What's my y-axis in this picture?
Or level of cognition?
Yeah, I'd call it predicted cognition,
Sorry.
something like that.
Okay.
And I would say predicted to illustrate, like, no, this is what the
Right.
model says, not what it is. Linear prediction is a term that you will hear in generalized linear modeling because that's the part of what we call, like, what the fixed effects do in your model. But that is not a useful axis. Also, note that what the scale of this axis is. It goes from 20 to 35. This variable ranges from 0 to 45. So this is kind of cheating. It's making the differences look magnified by really zeroing in on the y-axis.
You're honing in.
Yeah, you're honing in. So it's useful for pedagogical purposes. It's not useful if you're trying to describe, like, in the grand scheme of things, like, what is the range of prediction values? Like, they'd be much smaller if you stretched out the y-axis to be what it should be. So in homework 6, I'm going to make you generate predicted values. This is how you can do so very easily. No pictures, though, because I don't know how to make the homework system do that. All right, R, folks, I don't want to leave you out of the fun. Especially now when I have my functions in R working. So excited about this. All right, so here's my 2. And by the way, there is the same trick in R. If you change the colon to an asterisk, that puts all the lower order main effects underneath it, so you don't have to type them separately. So Stata, it's multiple hashtags. In R, it is a star instead of a colon. A colon just means this specific interaction term. All right, so then this model with the interactions accounted for that much of the variance. That's my R square. I'm using my custom function that adds confidence intervals to the end of the fixed effects table and formats the p-value a little more neatly. So this looks exactly the same as Stata output with one exception. The intercept is first. Stata always sticks it at the end. Always. I know, it makes me frustrated. It should go first, but no one asked me. I made a function that that spits out the f-test and the change in the R square and adds partial R square. So this is the output of that function. It wants to know what is your first baseline model, what is the augmented model, so I have the word full here, and then what do you want to call it on your output? So this is the result I get. So the original, the R square for my new model is this. Here's by how much it changed. Here's the f-test that we saw in Stata, and there's the p-value. And then a partial eta square for that would be here. Semi-partial is the exact same thing as R square change. That's what it is. Then to do simple slopes. This is slightly more painful in R. I know. Once you get used, yeah, it will. I know, but when you have like 37 predictors in your model and you have to type
That
this
could be-
out,
That would be frustrating.
I imagine there is a better way. I have not found it yet.
Okay.
Okay? I'm not saying it doesn't exist. I'm saying I haven't found it yet.
Hubby, can you fix this for me?
Yeah, exactly. I try to like not over ask, like you got to meter your requests.
Yes.
It's It's kind of like pick your battles, but it's more like pick your questions.
Well, you got one thing, next year, you can say, you did this thing from last year, did a great job. Now, here's a little thing could you do this year?
No, for my birthday 2 years ago, I actually asked him to make me an R package for this class.
Really? Did you get it?
No. But what I did get was he found Supernova, which did like 80% of what I wanted, is to build the sums of squares table. And I was happy with that. And then he showed me how to make functions, and I was able to make my own. So he sort of like, yeah.
These 5 functions is good.
It's like, it's just packaging output. However, I make absolutely no guarantees that this works on any other kind of model or any other kind of data. Like this is like, user beware, whatever. Caveat emptor? No. You didn't buy it. What's user beware in Latin? Caveat something. Anyone speak Latin? No? No say. I got Spanish, that's all I got. So, what these things are doing, remember what these are?
Mhm.
Multipliers.
Those are but that's the order and the output.
The
that you
order
got.
in the output. So, in these commands here, you are saying, I don't need an intercept. I do need one age slope, please. And if we're talking about men, then I don't need anything in the interaction term. If we're talking about women, I put a 1 there because that's what they're coded. For grip strength, likewise, I put the ones in the next spot where beta 2 goes, and then I have the moderators would be in the last spot instead. So this is why, by the way, that you have to put the 1s here in the Stata code. That's why I write it the way that I do, to put the 1s here. Like I'm trying to draw that parallel. That's what's happening. But you obviously don't need to type this, and you'll still get, like, it'll still just be that coefficient. In SAS, you need 1s as well. So get used to that. So I'm asking for these 4 linear combinations, saving those as an object, and then I'm feeding that object into another function that I made that adds confidence intervals to that object and spits out a p-value. Then we get into predicted values. And this is a package that I found by Googling, is there something like margins and Stata in R? And like this is what came up.
Cool.
Yeah. It's called prediction, and it works like Stata. So it wants to know what your model is. It wants to know what values of your predictors you have. So I have held dementia at 0. I have asked for grip strength in this range from -3 to 3 in intervals of 6, from -5 to 5 in intervals of 10 for age, and then between 0 and 1 for gender. So in your homework, make sure that any variable that is not like varying across the predictions is held at some value. Otherwise, it holds it at the mean of that variable, and it won't be the right prediction. So the default behavior of this is a little bit different.
Question.
Yeah.
For gender, you had 0:1. I get that. That's fine.
Yep.
My question is, could you have done the same thing with age, -5:5, or not, because it's a quantitative versus a.
I think if I did this, that I would get all of them in between.
Okay.
I'm not 100 on that, but I
Okay.
think that's what would happen.
Well, then my next question would be, could you have not had the colon on the gender and had comma and then by 1?
Yes, that would work too.
Okay.
Yeah, I think there's a couple different ways to ask for
And
these
that's
things.
fine. I just want to make sure I didn't have to do it differently for a different.
Yep. And so then it spits out the table.
Okay.
So I saved this and asked for a summary, then printed the summary, and then here's what we get. So it tells you like which values go with which. And the code to make pictures is ugly. And I needed help for that too. So it's online. I'll answer questions about it if folks want, but I wasn't going to do that to you. And then here's the pictures I made. And for reasons that are unclear, the lines, colors, and the legends only partially match, and I don't know why. So that'll be a for next time problem too.
Did this one actually go all the way down to 0 or no?
This
Okay,
one,
I wasn't sure.
yeah, this one I
was-
control the axes actually. So I told it 15 to 45 or whatever.
Okay, so you controlled the 0.
Yeah, in Stata, I think you can too. It's just
Yeah,
you have to
find
double
out.
click and then fuss with it. I'm not sure if there's code to do it or not to augment the pictures. There probably should be, but I don't know it. I don't know everything. That's the take-home message from today. I'm just telling you all the things I don't know yet. And because these interactions are not significant, the story of them would be pretty straightforward.
Short.
Yep. Although the augmented model, that means model with extra stuff in it, okay? That's a general term you'll see. Accounted for a significant amount of variance. F for the model is significant, R square there. The addition of the two interactions did not significantly improve prediction relative to the main effects model. Here's the change in the R square. Results indicated that the effects of age and grip strength did not differ significantly between men and women, and so these terms were removed. So that's all I would say about that. Okay, questions? How is this feeling? Thumb check? 2 thumbs up?
So as you're building your model, if you like add one variable, then you add another, so you're increasing on it. Would you need to do what you just did at every level of increase to see what's happening for significance and so forth?
I would. I would.
And then I'm just making sure, so when I'm working on the assignment, I'm like, okay, yep, I'm right when I need to do this, do stuff. Next one, do stuff.
Yeah, so it would not necessarily be the case that every time you do it hierarchically. Hierarchical models are when you have a designation of some predictors as like controls versus substantive things you care about. Like, I'm going to put all this control stuff in here that I don't care about. Now we're going to add the things that we do care about. But if you don't control for stuff first, then no one's going to believe you that you have this unique contribution of the new thing that you care about. Because one person's control is someone else's previous line of research. So if you have variables that have distinct roles like that, I think hierarchical models make sense. Otherwise, if you don't, it probably makes more sense to dump everything in
Just start.
and see what shakes out.
Okay.
Yeah, because like as I add things, the contributions of what was already there is going to shift around and be reduced. So like the story changes as you move along if you're building towards some final conclusion.
And if you are building hierarchically, if you encounter something with either little or zero effect, would you then just say, I'm not even going to include this in my final model, and I'm going to replace that step with a different one? Or you continue to build knowing that one had little impact?
That is a difference of opinion question. I think people would
Oh.
reasonably disagree.
Okay.
So from one perspective, like if I add something, it doesn't matter, I could kick it out, move along, add other stuff. However, the standard error for that slope, the numerator of it is formed from the current residual variance in your model for your outcome. So that means that if you add something initially and your model's terrible, it's not significant. But after you explain a bunch more variance, it could become significant later because the residual variance for it is smaller.
Okay.
So if you're worried about that, I'd leave it in. And I would leave it in the whole way probably until you get to where you decide like your done model is, and if it's still not significant, maybe you get rid of it at that point, or maybe you leave it in to make that point. Like if reviewer 3 is like, you didn't control for age, like I'd leave it in there. Look, I controlled for age, it's not significant, leave me alone. Like if part of your story is this doesn't matter, it needs to be in the model to say that it does not matter.
Okay.
That's my opinion. All right, 302. Rather than starting a new model, how about you have 15 minutes of your life back? Or 13 minutes of your life back, as it were. You're just good. He's like, I already packed up, I'm done.
You already checked out. 3:15 actually.
You go catch your bus then. Yes.
All right, thank you so much, everyone.
Yes, thank
Thank
you.
you.
Thank you for being
Have a
here.
nice break.
You too. Have good breaks. Take care of yourselves. Let me know if you need anything, and I'll see you on the other side. We're done for today. Bye, Zoomers.